Okay, so probably the easiest way to do this one is to take y1 as a sine kx minus omega t and y2 as a sine kx minus omega t plus phi. And then we just need to try and work out what phi is such that we want our resultant wave to have amplitude A. And we showed that y1 plus y2 is equal to 2a cos phi on 2 sine kx minus omega t plus phi on 2. So this is the travelling part of our resultant wave, and this here is its amplitude. So we need this amplitude to be equal to A. So we need 2a cos phi on 2 to be equal to A. So the a's cancel out, and we need cos of phi on 2 is equal to 1 divided by 2, or a half. And then we can work out what that is from our little trigonometry triangles. If we have an equilateral triangle with sides all 2 and we cut it in half, then this side still has length 2 and this side here has length 1, and that's a right angle triangle there. And then this side has length 3, and we want a half. So adjacent over hypotenuse for cos 1 over 2. So this is the angle that we want in here, and that's one of the angles on an equilateral triangle. So that angle in there is 60 degrees, or in radians, it is equal to pi on 3. So what we have is that phi on 2 is equal to pi on 3, because cos of pi on 3 is equal to a half. So this tells us that phi is equal to 2 pi on 3. So our waves, we can have y1 is equal to a sine kx minus omega t, and then we can choose our second wave as a sine kx minus omega t plus 2 pi on 3. So just to check this, here's the graphs drawn up in Mathematica. y1 is this blue line here, y2 is the green line, and you can see that the red line is the resultant, and it does have the same amplitude as both the green line and the blue line.